And our agenda for the next 20 to 25 minutes will be on the challenges faced by the stakeholders, the advantages of collaboration, the ideal scenario as we see it, the ability to work backwards, and then we'll showcase some project examples, give a brief introduction to Saskarc for any who are not familiar with it, and then we'll wrap up with some time for question and answers. And I'm sure many in the audience today will have questions, and we look forward to those and appreciate them, but I just ask we're going to do something a little different here and ask that everybody holds them till the time period at the end. So with that, I'd like to get started. I'm sure many in the audience have seen this slide before. It's been quite widely used in numerous industries and for many different things. And so what we have here is how the customer described it. And as we see, we have the two ropes coming down, 3 rungs going across, can swing freely. Then we have how the EPC understood it. We see it's quite different. We still have the 2 ropes. We have 1 rung now, and it's hitting the tree. So it's not going to swing very well. Then we have how the engineer designed it. And it's looking quite different again. Maybe a little bit over-designed, quite fancy. Now we have how the fabricator manufactured it. So now we have the ropes again, the 1 rung can swing, a little bit of different approach to it. And then we have what the customer actually wanted, and it's very different again. So we just use this to illustrate the need of collaboration among all the key stakeholders. And I think everyone in the audience is very experienced in the industry. They understand, and I think we see it across all the different stakeholders, the importance and the need for collaboration, right from the owner level down through the EPC when one's involved, through the fabricator, the modularizer, the freight company, and then onto the field contractors that's erected. So I'd just like to ask the audience if they've ever experienced cost and time overruns in projects. I just ask that the audience puts up their hand if they've ever experienced cost or time overruns. Misinterpretation or miscommunication of project requirements. Again, I'd ask if everyone puts up their hand that's experienced that. So we do see it quite a number, and we've certainly experienced it in our company, and so we can relate to it. I think many here can. And with that, as we go through our presentation, from our perspective, we're just going to provide what we think are some possible solutions to help alleviate that. And again, it's from the fabricator's perspective, and specifically ours, but I think we'll find it quite interesting as we go. So as we get started here, I'd just like to showcase a project that we were involved in. It was a large oil sands project for Alberta, and it was a project where the engineering was already designed when we became involved. It was already, and it was complete. And the engineer designed the structural steel and specified it as 350W because it was a Canadian project, which is understandable. But 350W is not a common material grade anymore in Canada for structural steel. In fact, I don't think there's any mills in Canada that would actually run on a standard basis 350W. And the standard grade is, for that structural steel material, is 572 grade 50 or 8992, which is very readily available. And the reason I wanted to showcase this project is by us becoming involved as the fabricator, we were able to compress the schedule by 12 weeks just by understanding and recognizing that and going back to our client, the EPC, and telling them or recommending to them that if we switch the material grade, there would be this schedule savings. And just wanted to showcase that to you to give an example of what can come about through project collaboration. So I'd like to ask, if you had access to the fabricator's expertise during the design stage, would it help you? And it's a topic that we've covered quite a bit over the last couple of days. And I think what it would help do, from our perspective, is it would help eliminate change orders, costs, as well as potential schedule delays and impacts. Improve open lines of communication between the key stakeholders throughout the project. So in today's project process, as we see it, it follows what we see up on that screen right now. Starts off at the owner at the top level. They have a project, they sanction it, then it goes down, typically awarded to an EPC. They become involved and start the design process. Then it goes down from there and to the fabricator. It's awarded to the fabricator. By that point, usually in the projects we're involved in, the design's already complete. And so we build it as the design is done. And what's happening in most cases is now we're going back up with, is we're having to go back to the engineer, because maybe there is something designed so it's not easily constructible. Maybe there's a material grade that's not readily available, has a long lead time item, when something much more readily available could have been used. An example is that we often see is a heavy MC channel is used, which is about 3 times the cost of just a standard wide flange beam. Typically, as a mill run, you got to order large quantities, when in fact a slightly larger wide flange beam could be used in the same situation at a third the cost and much more readily available. As well as we saw before with the material grade, often material grades can be, the codes allow slight changes or a different material grade, much more readily available. Often the cost is considerably less. And coming from the fabricator's perspective, we see that. We're involved in it on a daily basis with through our purchasing team, our construction team, and so we're often able to provide that advice and save having to go back up if we're involved earlier on in the design stage. And what that rolls up into is the fabricator has to quote a higher price, because when they're looking at it with their team, they realize that it's not as constructible, it's maybe not done in the best manner from a constructability perspective, or weldability. Maybe there's some areas that are really hard to get to weld, so it takes more time, or you have to step through the process, or as we spoke to before, the material grade's not readily available, so it costs more, longer lead times, so then there's a schedule crush and got to work overtime, and then there's also the more expensive member sizes, so it often impacts the schedule because additional man hours are needed. And then the fabricator, just from their experience on different projects through the industry, they often have a lot of experience they can bring to the table just in how the project could be modularized. Maybe there's something that the EPC never thought of or never saw. We see that quite a bit, especially we're seeing a lot in projects both in Alberta and Saskatchewan, and we get the project and we're like, well, why didn't we do it? Did they do it this way, or here's something that could have been modularized, and it's just the advantage of having that collaboration early on. So the ideal scenario, as we see it, is really a paradigm shift in the fabricator stage of involvement, and it's something that's came up a few times yesterday through the different sessions, and it's come up again this morning. It's just the owner sanctions the project, so it's going through the same process at that level. Then the EPC becomes involved and they start the preliminary design, and then at that point they share the design with the fabricator. And what we're often seeing is at that point it may just be a very undetailed drawing, very low level, sometimes not much more than a napkin drawing, like 2 or 3 drawings just showing the overall project. They'll assign a confidentiality agreement, share with us that information, and then we'll look at it with our team and provide feedback and say, recommendations of what we see. Keeps the information flowing down, the project's continually going down versus having to go back in that cycle of flowing upward. And we all know that when you're traveling somewhere, it's always better when you're driving straight ahead versus driving ahead and then backward. You get there a lot quicker when you're driving straight ahead. So what it does for the owner and the EPC, it's eliminating unnecessary costs, and it's really providing those savings back through the EPC to the owner to help their overall project budget and their overall schedule. And we've received a lot of positive feedback on it so far. We've met with a number of the key EPC and owner companies through 2013, and so far we've received excellent feedback. They're very open and receptive to it, and I think we saw coming through the last day and a half that many of the people here today are quite open to it as well. So here we have the key stakeholders. And we have the owner of the EPC, then the fabricator, the field contractor, as well as we have the freight, who we show here is really the oil that is required as well. They're all very important, they're all required. They all need to work closely together to ensure the project is successful. And it takes all of them to pull a project off successfully. And what's that result in? It results in cost savings, which again, like we mentioned before, that goes back up eventually to the owner, brings all the different perspectives together of the stakeholders as they're all involved and work together, open lines of communication. And then it really brings about an increased accountability because everybody's involved, they all have their input, and it really brings the accountability back to the individual stakeholders to ensure that they're following through with their commitments. And we spoke about the ability to work backwards, and that's more what we're seeing right now in today's market. Where and to be clear, the fabricator can still provide advantages and recommendations at this stage, but the advantage and the return is not as great as if they're involved earlier on. And how we do it ourselves is if there's small savings, if as we're going through the project it's already designed and we recognize small savings, we'll detail that in our quote and provide that back to our customers. When there's larger savings, when we get the package and review it, maybe we identify some options for modularization that weren't considered, or some material grade savings, or might be member sizes or anything to that extent. We'll go back to our customer and provide them some recommendations early on for their consideration. And what we often find is they're very open and receptive to it, but they want us to quote the base quote so that they can compare it apples to apples with the other vendors, but then they also want the optional pricing for what we're proposing. And then when we provide that optional pricing, we're finding that in the main, they're taking that because they see the advantages, as we've spoken to today, of bringing man-hours off-site. So here we'd just like to showcase a recent project. It's actually one that we're just finishing up now. It's for a potash mine, actually in Saskatchewan. It was a head-frame project where our customer went out with the project. They were planning on getting it all as stick steel. They were going to modularize it in on-site. And it was in a very remote location during what their schedule is during the coldest winter months of the year, which I think we can all relate to what the cold weather's like in Saskatchewan when it's minus 50 and the wind's blowing on you and the snow's falling down, and it can just be very, very unproductive to work. And so when we received the package, we looked at it with our team and saw the possibility of modularizing it, went back to them, offered it as a suggestion and a recommendation, and then they came back, as we spoke to before, wanted it, the original price or quote as requested, as well as the modularized option. And when we provided it to them, the modularized option, they went ahead with it, reviewed it with their team, and went ahead with it. And really what it's like is, which, I mean, everyone here is quite familiar with modularization, but what we offered here is kind of like taking, when we were little kids and playing with Lego or Meccano, and it's just taking all the stick steel components or the small platework components and just putting them together and then providing that back to in the controlled shop environment versus in the field. And for this specific project, for the large bins, we did them in our large fabrication facility, put them all together and welded them out, and then the modules we did in our modularization shop. So we were able to bring that all out of the cold weather into a controlled environment. And what we would typically provide on a project where we're offering something different is, as we see on the screen here, a detailed bid comparison. As we see it, we'll detail it on the one side, the cost in the field, lost productivity, the cost of traveling into remote locations, getting room and board, the expensive cost of getting cranes in there and other equipment, as well as just the lost productivity. And then there's the increased safety risk. As you have more hours on site, the safety risk increases. So we'll factor all that in on one side over against what it costs to do it in our controlled environment, provide that to our client, and then they can see across the bottom line what the difference is and what their savings are. As we spoke to before, the freight companies are very important, and there's a few of them here today. And we work closely with most of the major over-dimensional freight companies in Western Canada. And we have a couple of projects that we just put on here for some examples. On the top, we have a large module that we did for a potash company, and then the bottom is a large module we did for the oil sands. And as a fabricator, we work very closely with the freight companies during the preliminary stage. If route survey is required, if we need to work with the government bodies or local authorities to ensure we can ship it, we facilitate that, because as I'm sure everyone in the audience can relate to, you don't want to get a project half built and then find out it can't actually be shipped. That's not good. So early on in the phase, we will work with our freight vendors to go out and ensure that it can be effectively and safely shipped. So I'm sure many in the audience are wondering, what is the fabricator's involvement and commitment? And we can't speak on behalf of the other fabricators today, but we can speak to what we're committed to as a company. And what that is we're committed to our clients to bridge the gap between what our clients realized or sometimes even unrealized challenges are. And we're committed to providing that through doing that early stage of constructability and material grade and weldability and member size review, as well as anything else we may see when reviewing it. And like I spoke to before, we do still do that post-design stage, but I think we recognize, and many here today are as well, as the advantage of involving the fabricator, and then the same thing applies to the constructor, involving them early on in the stage. And then we'll provide that through our recommendations back through a quote. So before we move on to the Q&A session, I'd just like to briefly introduce Saskarc to the audience for anyone who's not familiar with it. And we're a large custom steel fabricator located in southeast Saskatchewan, specializing in large modularized components. And we do about 50% of our work in Saskatchewan, and the other 50% would be in Alberta, mainly for northern Alberta and the oil sands industry. And we can be extremely competitive. We are a bit further away than the Edmonton fabricators, but our labor costs are slightly lower, and the freight costs are not much more. So we found we can be very competitive in that market. We also offer many value-added services through our key group of qualified subcontractors working out of our location. We bring them into our location and facilitate it through our quality control and product management teams. And a number of those value-added services are insulating, cladding, blasting and painting, piping, electrical, etc. And we just have a few examples up here of some recent projects that we've done where we've brought in those different value-added services to provide our vendors basically a one-stop solution, so that they're only having to provide one purchase order, and it's easier to facilitate through one company when everything's at one location, to allow them to, if they have to send in inspectors or any of their team, it's easier just to travel to one location and more cost effective. We also have an equipment group specializing in core areas of industrial site equipment. And we have, as I mentioned before, two large facilities. We have a large fabrication facility, as well as we have a large modularization facility. And with over 14 acres of graded laydown and modularization yard and over 70 employees, we're well situated to take on multiple projects simultaneously. So in summary, earlier on we had many hands raised. So the recommendation I'd like to provide is that we do proceed with this industry paradigm shift. It's going to happen. It's just a matter of time. So the sooner that everybody takes advantage of it, the sooner that the benefits can be realized through utilizing the fabricator's expertise and as we mentioned, the constructor's expertise, and bringing it to play, so that the owner and the EPC are able to enjoy the cost and time savings of doing that, and then the increased communication and collaboration throughout the stakeholders to ensure that the best case outcome is achieved. So in closing, I'd like to thank everyone and then open up the floor for any questions.